Welcome back and let's prep for better jobs. Today we're solving add two numbers, the second most popular interview question. We're given two linked lists where the digits are stored in reverse order and we must add the two numbers, then return that as a linked list. To start off, I'll explain the problem. The main thing to note here is that all of these nodes can only store a single digit of information, so just one single number of 0 to 9. And this is going to be a big thing to remember once we get to the optimized solution. But how this is going to work is if you look at all these, they're stored in reverse order. So instead of 243, this first node is 342. So we have 342. This one is 465 reverse. You add these together and you get 807. Now we're not storing 807. We have to store it in reverse order. So the 8 goes there, 0 to there, and then the 7 over here. Now for solving this, I'm going to skip the brute force solution and go straight into the optimal approach. And the trick here is remember how I recalled at the first part of the video that it says every node contains just a single digit. We can use this fact to our advantage and then we can do long addition on this. And I'll go through this. So first what we do is we look at the first column here. We do this basically back to front. So 5 and 2, we add those together. We get 7, so we place the 7 here. Then we add the 6 and the 4. So 4 plus 6, we get 10. Now we want to take this left digit here and we want to carry this over to the next one. And then we take the 0 and we place it right there. And then we add these up, 4, 3, and 1, and we get 8. So now 807. Now let's do one more example of this as a quick refresher, one with a little more numbers. So let's add 986 and then 1815. Okay, so add 6 plus 5, we get 11. Carry the left digit, take the right digit, place it right there. Then we add this and we get 10. So 1 plus 8 plus 1 equals to 10. We take the left digit, carry it, place the 0. Then we add 1 plus 9 plus 8. That will give us to 18. Carry the left digit, place the 8. Then we add 1 plus 2. And then here we have it, 2801. All right, and now that you know how to do long addition, we can go into how to do this actual problem with the linked lists involved. And the main thing to note here are these are stored in reverse order. And this is really helpful for us because if these were not in reverse order, we would have 2, 4, 3, 5, 6, 4. All right, now we have these, but if you remember, we're passed pointers to the head of this list and pointers to the head of this list. So we're then to only be starting at our iterations at 5 and 2. But we have to do our long division starting at the back. We want to start right here. But these are given to us in reverse order. So let me rewrite this list. If we write our list as 2, 4, and then 3, all I did is I wrote this backwards, where you can see 2 goes to 4, 4 goes to 3. So I wrote it as 2 goes to 4, 4 goes to 3, but I wrote it in the reverse, kind of right to left way. And then we can also write the other one as that, where it's 5, which points to 6, which points to 4. All right, so I just cleared my drawing pad because that was kind of messy and I'm going to rewrite this all. Now to do this, we have to iterate through our linked list. So we can have a P1 pointing to there, a pointer 2 pointing to this one. So we know these are digits, so we can go look at the node value at P1, which is 3, node value at P2, which is 5, and we can place 8 right there. Then we take our pointers, remove P1 pointing to 3, P2 now points to 6. So we add them. 4 plus 6 is equal to 10. We have to place the 0 here. We have to carry the 1. So how we can carry this is we can just create another quick variable, carry. The carry goes right to there. We move P1 over to 2. P2 now goes to 4. We add the two node values, 2 plus 4, plus our carry, which is 1. That gives us 7. We place the 7 here, and then we get 708. And now one quick edge case for this is you can't have a situation where we add, let's say this was 8 and a 3 over here. You would place this value like a 0 here, and you would also have a carry over to the left. So sometimes you have to basically, even though P1 and P2 are finished iterating, right at the end of this, you also have to check the carry at the end and make sure you place it correctly right down there. All right, now let's jump into coding this. So the first thing I do is create a carry value, and then I want to have a dummy node. So the carry is initialized to 0. The dummy node is going to be a new list node, and then I want to also create a current node, and I set this to dummy. Now, if you're confused on why I'm creating a dummy node and then I'm setting current equal to dummy, I'm going to link a video right in the description. It's going to be the first link, and that is going to tell you exactly what this concept of having a current node and a dummy is. It's a very common thing to do in linked list questions, and it cleans up your code a lot, so I would highly encourage you to watch that. Now with that out of the way, we can do while L1 or L2, and then we want to get the value at these nodes. And since that these lists could be skewed, like for example, the first list could be 1,000,000 elements and the second list could be only 3 elements. There could be situations where value 1 is something and then value 2 is just nothing. So I'm going to do v1 is equal to v1.val if v1, or sorry, this should be L1. So v1 is equal to L1.val if L1, else 0. Then I do the same thing for value 2, L2.val if L2, else 0. So now we add these, so it's going to be result is equal to v1 plus v2 plus our carry value. Now I'm assuming this is where a lot of you will get tripped up, because it's where I struggled with when I first did this, is you have this result here, but now you need to get the carry value for the next iteration, and you need to set your new node in your result list. So for example, if our result is 15, we want to get the 5, the rightmost value, and that is going to be the value of our new node. So we can get that if we do 15 and we mod it by 10, it's going to strip off the rightmost value, so the 5. So here we can do current.next is equal to list node, and we pass in the result modded by 15, or sorry, modded by 10. So for this example, if our result was 15, we're going to set the new value of the node 5. And then we also want to set this current is equal to current.next. This is just for the next iteration. And then lastly, we want to set our carry value here. So if we want to get the 1 as the carry, instead of doing mod 10, we do 15, do the double division operator, get 1. So carry is equal to result over 10. All right, now we have to set L1 pointers and L2 pointers. So L1 is equal to L1.next if L1, otherwise we just set this to none. Now do the same thing for the next list, L2. So now at the end, there's one edge case you really got to be aware of for this question, and that is if you look at this example 1, our last node values here are 3 and 4, but what if these were like 8 and 9, but then you'd have a carry value at the end and we never do anything with that. So here we want to check for that. So if carry is not equal to 0, we want to set current.next is equal to a list node of carry. Now at the end, we're going to do a little bit more of our dummy list here. So dummy, return dummy.next. All right, now we run that, it's accepted. We can submit it and you can see it's accepted. So thanks for watching.